Okay, guys, here is the example question on optimization. Let's read the question together. A regular paddock to enclose sheep is made by using the wall of shearing shed as one side and the wire mesh for the remaining three sides. Okay, so now from the picture, we can see that this side is the wall and then there are three sides by the wire. Given that there is 110 of wire mesh fencing available. So, okay, now we are talking about using the minimum material. Okay, so it is obviously a local minimum. Okay, so first show that y equals to 110 take 2x. Okay, this is pretty easy because if you imagine that's the wall, I could have different ways to span these 110 meters of wire mesh. I could have a really narrow one, whereas it's quite long. I could have a that way. But really, which way is the most efficient way to span these 110 meters of wire mesh? I want something that to have the largest area. Does that make sense? Okay, because if I have something that largest area, I could actually keep more sheep. So that's the question that we are interested in. So let's do question A. Show that y equals to 110 take 2x. It is a rectangle shape. So if this is x, therefore that's my x too. So I could actually easily calculate by just doing 2x plus y equals to 110 meters. So just by rearranging, if I take 2x on both sides, I have y equals to 110 take 2x. Make sense? So question 1 done. Let's have a look at question B. Show that the area of the paddock can be given by the expression this. Okay, we all know that the area of rectangle is the width times the length. Okay, so the area I can do as x times y. And from the previous one, I already had an expression for y. So to make y the subject using x to represent y. So how about I sub this y into that one? Let's try that. So that equals to x times, just going to use another color, 110 take 2x. Make sense? Okay, and then it's very easy. I just need to open it. I'm just going to use another color. When I try to open it, I actually times each one. Equals to 110x take 2x to the power of 2. And then the thing that the question gave is, with the highest power in front, which is actually common sense. So we want to do the same by just writing negative 2x2 plus 110x. Okay, A equals to that. So that is pretty straightforward. Let's keep going, have a look at the later one. So find the maximum area of the paddock, and the dimensions of the paddock that will give is maximum. Now we are moving down to area. Okay, so we are moving down to the maximum area. Okay, so why don't we just continue with what we had here? That's the area to represent, using x to represent the area. So now we're down to one variable here. Okay, so we could actually using these, and this is a quadratic equation, quadratic function. So we could actually using these to calculate the maximum area. Okay, so A equals to negative 2x2 plus 110x. Okay, what you can do is you have method 1 using graphic calculator according to my video yesterday. you should be able to, using graphic calculator, to plot. So the graph should look something like this. That's your y, that's your x. Okay, so it's gonna pass the origin, and the other part is gonna be half of 55. Okay, but I'm also going to show you how to do them algebraically, because I believe doing things algebraically is very good for you. So let's do that. We're interested in the maximum. So basically what we're interested in is this point. We also call this a vertex. And this is also the axis of symmetry. Does that make sense? So if I can just do a completing the square, -2, x2, take 55x. My first step. And then I can try to do the completing square, x take half of 55 to the power of 2, and these again, x2 take 55x plus 255 to the power of 2. So therefore I have to take 55 to the power of 2. So that is my completing the square, because there's no term after 55x, so I don't really need to add anything or take anything. So that's basically is my completing the square. And then if I open it, I could have a equals to -2, x take 55 to the power of 2 plus, because it's 2 negative, then become plus 255 to the power of 2. Okay, so we end up with a expression like this, right? Okay, now we know that x equals to 55 over 2. This is the axis of symmetry. Okay, so and this is also the point where the quadratic will give its local maximum. Okay, so and the question asks the dimension of the paddock that will give its maximum. So we know that x should be half of 55. In other words, that's 27.5 meters. Okay. Okay, now it also wants you to find the maximum area. So really, the maximum area is, because if I sub this one into here, this part will become 0. Therefore, A is 2 times 455 to the power of 2. So I'll have to use calculator to see what does that equal to, because you could actually cancel the 2 with the 4. And then now I'm just gonna use my calculator to calculate 55 times 55 divide by 2, 1512.5. Okay, but this is method 2. I would highly encourage you to understand this method. Okay, I highly encourage you to understand this method. This is to solve algebraically, and this is really, really good thinking. But if you really stuck, you can actually use your graphic calculator, which is very, very easy. All you need to do is you put these into your calculator, and then you could use the GSolve to find the local maximum, where you have the x and y coordinate of the local maximum, and then you can get this value and this value together. Because really what these two values are is actually the vertex. So therefore the vertex of this function is 27.51512.5. Okay, so these, I'm just going to label that there, is actually the vertex. Okay, but again, I highly encourage that you should understand this method. Okay, see how you go.